Hi everyone, I hope you are all fine and welcome to Autodesk PowerMill. So we are going to start a very exciting topic and exciting module, which is module 6, all about the Toolpath Simulation. And in this module, we have some exciting topics like study about the advanced simulation features. We're going to study about the error and collision detection, and then we are going to study about the part inspection. So it's a very small module, but it contains very exciting topics. So we'll go and start with the advanced simulation features. So let's get started. So I have opened the Autodesk PowerMill May 2024 version, and in this video, we are going to study about the simulation. So all the way from module number 1 to module number 5, we've just discussed about all the types of toolpath and toolpath strategies, starting from the 2D tools and then 2D toolpaths and 3D and 3D toolpaths, and we have finishing toolpaths, roofing toolpaths, and all the way we discussed about the filings and machining, the previous module. So what we have to do is we have to know about how we can go and check our simulation and we create a tool. So simulation is a very important in creating the toolpaths. For example, when you are going to do the real work on the machine, you should have to check whether our program is correctly being made, or is there any problems in the program so that we can check it. And if errors occurs or some toolpath gauges and some collisions are detected, then you can easily remove them and then make a final copy with no errors and no collisions and no gauges. And then you can put the program into the machine or forward the program to the machine. So that's the purpose of simulation is going to be happen in the CAM software, and that's a very powerful tool given by the Autodesk Power software. So we can perform any type of simulation. It's going to be 2D simulation, 3D simulation, and with the machine. If you have a machine file, you can just put your machine file into the simulation, and then you can perform the real-time simulation how the cutting tool is going to perform its operations. So let's get started. I just go and create a model, and I'm just going to put a model in the SolidWorks, and let's go and check out the famous model, which is Colin.dgk. I just put it, and see that this is the surface model, and what we are going to do is we just go and create some toolpaths so that we can able to check our simulation, and we'll just find out where are the errors, where are the gauges, and where are the collisions occur. And after doing all these things, we can move the collisions and all these things, and then we can send the program, or our program is going to be ready for the machining. So let's go and click on the hole and create a block. You can see that create a raw material setup for a block from the model. So here we have a block, and that contains the model. Click accept and it's done. Or just go and create a work plane. And the work planes are different. You can just go and select the work plane aligned to geometry. That would be very much easy. You can set up at any place or any store, or you have multiple options as well according to the workpiece or work plane position of the block. So you will get different points on the block, and you can set up the work plane accordingly. So I just go and click on the center. And what I have to do is I'll have to activate the work plane. So how we can go and activate the work plane? Just go and click on the manager area or explore area and find the work plane. This is the one work plane which I have created. and right-click the work plane as right-click and hit add. So that work plane is going to be added, but the block position and the model position is going to change. What we can do is just go and click on the block again and apply the or calculate the balls. Click accept, everything is going to be right. Now just go and click on the work plane and you can just go and rename that block as well. Just write it W1 for work plane. Now the next thing is that we have to apply some toolpaths technique. So before getting into toolpaths, let me decide some roofing operation tool. So here I'm going to apply the anvil tool, and let's say that it's going to be 10 millimeter anvil tool with the length of 75 millimeter, and I'm going to write the name then and then FEF. That will be flat and mill. That's okay. If you want to set up the holder, you can just go click on the holder, click on the add border component, and you see that it's going to be showing you everything. Like the upper diameter is going to be 15, lower diameter is 15. The length of the tool is 75. You see that the length of the tool is 7. But the yellow area which is being on is the 45. So the overhang tool is 45. This means that some of the tool is going to be entered into the tool holder for clamping purpose. Or you can also increase the length as well. I just want to make it 50 degrees. So now the 50 tool is outside and the other side of material is going to be inside of the holder. We'll just go and set up the upper diameter of the tool holder if you are using the conical type tool holders. So let's go and make it 40, and the lower diameter is going to be set as 25. That would be great. You can set up the tool holder name as well, but I'll just go and write the name at 1. So just go and click on the tip over here. You can set up the tool number 1 with the fruits of 4. So that's going to be the material, and click close and it's done. Now just go and click on the toolpaths because we are going to apply the toolpaths on that thing. And the first thing we have to apply is the roofing option, right? Just go and click on the model area because this is the model. I just want to make my work area is going to clean because we have store over here. So click OK and it's done. I'm going to make this thing a little bit faster because I've already discussed all these things. We have to go to the simulation. Okay. So just go and click that ball. Tool is started. Model thickness 0.05. So 0.05. Step 5. Step down is going to be 2.0. Everything is going to be set to 1. Lead in and lead out needs get use CAM and speed and lead and speed. Make it 5 and get it. So I just go and calculate the tool path, and it's going to be calculate the tool path according to the model we have. So it's going to give you a warning of the plan rules into stock exist at start of some tool path segment. So what you can do is just go and click OK and wait, it's ready. So that's the thing. That's the toolpath which is being made by the PowerMill toolpath techniques. And what we're going to do is we're going to study about the simulation. So when you go and click on the simulation tab, you will find out something like the simulation path. So every toolpath you have created is going to be shown here that you have created a toolpath with a name already clearance. So right, we have only one toolpath, so only one toolpath is going to be shown. And the next thing is about the tool. We have tool with a 10 millimeter flat, and wheel is going to be selected automatically. But if you are using the model area clearance with multiple model area clearance and multiple tools, then you have to select the required tool, which is going to be fitted with the clearance. So here is the what we call the simulation path operation. Then we have to set up the simulation control. So here we have to control the simulation as well. While we're going to make it from play, incremental mode of the play, from point to point. Okay, some CNC items, components. Step forward, you can also control the peak by it's going to be 15% of T into feet rate. So that's the thing. So you can go and increase it. For example, if I go and play the button, you can see that it's going to create a simulation of the toolbar, and it's going to take 10%. So if I go and click more, you can see that it's going to be getting fast and fast. So the percentage of the operation is going to be shown at the lower left column with the simulation 6% coverage, and the bar, which is shown in like greens, like it's going to be filled out. That would be the operation progress bar, and that progress bar showing that how much of the toolpath is going to be with. The next thing is that you can find out the display issues or display the simulation issue dialog box and play and check. Then we have machine tool option, then tool option. Whether it's going to tool the basic tool or anything, just go and click on the play. You can see that the tool position is going to be shown. That will be at Z18.2. So everything is going to be shown right here with the tool position, and if you go and click on the machine tool, then it's going to tell you that which axis is going to be moved. So here you can see that there's the 3-axis machine. So it's going to tell you that it's going to take 3 axes of controller. So X-axis and its position, then Y-axis in its position, and also the Z-axis in its position right now. The position is at 6.42 some value. So that's what we call the machine tool position. And then if you want to perform the operation on the view mill, that would be converted your toolpath to real view, that how the material is going to be cut down. So just go and go to beginning view and click on this red icon, which will be show you the view mill position. It's going to take some time. So you see that the stock is being converted into solid and the toolpath is being shown. And how it's going to be show you that if you go and click on the play button, you see that the cutting tool cut down the material actual way through which you can look at your workpiece, how it's going to cut down the material. Also, you can also check the gauges and precision of the tool, whether it's going to cut down the material in an accurate way or in an inaccurate way. So everything is going to be show you in the view mill option. And if you want to turn off that thing, you can just go and click on it to suspend the operation. You can also click on the exit view mill operation to exit the view. The next thing is that if you have multiple shades, like if you want to show you no image, that's going to be show you no image option. Then rotatable option we have, just go to click on, see that's going to be the rotatable view of that thing. Then just go and click on the fixed direction is going to be produce the operation in a fixed direction like this one. See that? This is what we call the fixed direction view. And then if you go and click on the plane, you want to set the view mill in plain color, shiny color. It's something we can do in a very shiny way. Then just go and click on the rainbow. We convert in colorful way. The amount of toolpath which is going to be applied is going to have a single separated color so that you can able to see all the origin, the different colors and identify them. So that's what we call the rainbow color. Then we have the cut direction view. If you just go and click over here, you're able to see that how the cutting is going to be performed. We're using the cut direction or cut coloring option. Then we have the kinematic. If you go and click on the kinematic view, you can just go and click on the Z-axis view. It's going to tell you that this is the way through which the tool is going to be performed in accordance with the color. Okay. Then we have other operations as well. If you go and click on the view mill option, then it's going to show you that flow wheel operation. Click on it. And you can just go click on the model view. So you can able to see the model, how the model is going to be produced. And if you click on the tool view option, and it's going to tell you that how the tool is going to move. So you see that the tool move. And actually, this is what actually looks like. But most probably we use the flow view, see the working of your tool paths and all these things. So we just find out that there is no such gauge is available and there is no such Booleans available in the simulation, and the simulation is going to be worth verified. Because the thing is that the computer is automatically calculates all the parameters, especially the gauges and all these things. That's why it makes it take. So in the next topic, we just go and discuss about what are the errors and what are the players being created in the and how we can just go and identify them, repair them, or check them. Okay. So that's it for the simulation operation or simulation in the PowerMill Ultimate 2024. Thank you.